Welcome to Finchley College. Hi, in this lesson we're going to talk about total station programs and what generally total stations do. One of the main programs of total station is surveying, and the next one is setting out, then is the free station, then tie distance, remote height, reference line, area calculation, traverses, and roadworks. The main program is surveying, and as we talked about what the surveying does, you will set up your total station. The total station is set up, you will sight to a point, for example point A. The instrument already knows its coordinate, station point is called O. He knows his easting, he knows his northing, he knows his height. He will sight to a point. The instrument knows his whole circle bearing. He will show it on the screen. And the whole circle bearing will be shown on the screen. And you press measure. And it will measure the distance. And then it will display the coordinate of the point you're surveying. So that is as simple as that. You will set up the instrument, you know its position, you will sight to any point you want to survey, you know measure the distance, and you calculate its position, and it will show on the screen. The setting out program is the opposite of surveying. You know the point to set out, you know its position. For example, you want to set out this point C, you know its coordinate, you know its east, north, and height, but you don't know where it is on site. So you tell the coordinate instrument the coordinate you want to set out. He knows his own coordinate. He will immediately create a right angle triangle, and based on that triangle, he will calculate the difference in easting and the difference in northing between itself and that point. So on a rectangular coordinate system, for example, the instrument can be set up here, and you're trying to set out this point, point C for example. The instrument immediately calculates the difference in easting and the difference in northing between itself and that point, and based on that, you can calculate the whole circle bearing that you will need to turn and the distance that you need to measure. So then it will display to you the whole circle bearing and the distance to measure. You will turn the instrument to that bearing and you measure that distance, and that will be your point. So setting out is very simple, straightforward. You calculate where the instrument is positioned, you will tell what point you want to set out. It will simply give you these two information. You will turn the instrument and you will set it out. The free station program is one of the most important programs with the total station. With the free station program, your instrument, for example, is set up, when we go here, the instrument is set up here. You will sight to a minimum 2 known points, say R1, R2, so these are 2 retro points, retro targets with control point. You know their coordinates, you know the easting, northing, and height for both. The instrument will create a triangle where itself is 1 point and the other 2 are those control points. You will measure the distance to each of these, as the instrument will calculate the angle as you turn from one to the other. It will calculate the angle, and it will calculate his own position. So the job of the free station program is to work out what is the position of the instrument in relation to the grid system, in relation whether it's here, or it's here. He wants to know what is my coordinates in relation to the coordinate system. So he will display this. It will also display an accuracy in horizontal distance, accuracy in height, and accuracy in angle measurement. If you need 2 as a minimum, but if you add another point, a third point, now you'll have 3 triangles, 1 triangle, 2 triangles, and 3 triangles. So by adding an extra point, Instead of having just one triangle, it will have three. Therefore, it will calculate three values, and it will show you the average of all three results. And that will be more accurate, so therefore your accuracy will improve. So the free station program is something that you'll be doing all the time, every maybe 10 times, 20 times in a day. Every time you set up instrument in a new position, you will go to the free station program and you will calculate your location and where you are on the system. And then once you've done that, then you can do your setting out and surveying or any other program. So the instrument in reality cannot do anything meaningful until you've performed the free station program or resection, sometimes called resection, sometimes called free station, and you've worked out the position of the instrument in relation to your grid system. The next program, popular program, is a tie distance program. With the tie distance, you work out the distance between 2 points. You have a point in here, A, you have a point here, B. You could set up in here and side to A, and you press all, and you side to B, and you press all. The instrument will calculate the distance between A to B. It will show you horizontal distance is that distance, slope distance, SD, is that distance, and the vertical distance is that distance. It will show you all three, slope, horizontal, and vertical between A and B. So in reality, A and B is like that. That's the horizontal distance, that's your slope, and that's the difference in height. The advantage of tie distance is quite a lot. For example, you're surveying a road, you can side to one point of the road, another point, and you find the width of the road. You may have a building, you set up here, you side to one point, you side to the other side, and you can measure the width of the building or even measure the height of the building to the tie distance program. The tie distance program, you can do that in two ways. You've got a polygonal or radial. With the polygonal, you go from A, you measure distance from A to B, and then B to C, then C to D, then D to E. So you're measuring A to B, B to C, C to D, D to E. This is advantageous if you want to go around perimeter, measure, for example, you have a car park and you want to measure the size of the car park, you can set up here, side to here, side to here, side to every point, and that will show you the distance for every side separately. With the radial, is different. With the radial is that you side to the first point, then you side to the second point. It gives you distance between first to second. Then you side to the third point. It gives you distance from first to third. Then you side to another point. It gives you distance from first to fourth. So the distances, so essentially you set up here, you side to this point, you first, then you side to second, then you side to third, then you side to fourth, side to fifth. The dimensions always from first, 1 to 2, 1 to 3, 1 to 4, 1 to 5. Is from the first one you side to, and that is radial. The advantage of radial is in measuring the height differences for a floor. Say for example, this is a room. You want to check whether the room is level. You can set up side, say, set up here, side to the door threshold, and then side to various points on the room, and just check the height difference. You're noting the height difference there. You're noting the height difference, and the height difference hopefully should be 0 or 1 or 2 mil. So radial is advantageous for that. The next program is remote height. The remote height does the same similar job as tie distance. For example, you set up here, you want to measure the height of this building in front of you. You can side to the bottom of the building and then press all, measure its position, and then simply side to the top of the building. And as you side from the bottom to the top, the instrument will show you the height. It will show you the height from here to every point that you're starting, say top of the building. So the remote height is advantageous for sighting to the points that you can't measure. For example, it could be a cable. A cable is too thin maybe for a signal to return. You can't sight to a cable up in the sky and for the signal to return. So the advantage with that would be you sit up on the floor and sight to the floor and then sight to the cable, and that will tell you the difference in height. The other advantage of the remote height is that, for example, you've got a building and you've got windows and you want to measure the height of these windows. You can simply sight to the bottom and then sight to the top, and that gives you the height of the window. And you can sight to this one, that will tell you the difference between the windows. So as you go up, it will show you the height for each. The reference, so that was the remote height. The reference line program is when you want to set out, say, a number of things that are in line. For example, you're setting out several piles that are in line or in sort of regular pattern. Instead of giving the coordinate for each pile to set out, the coordinates may be very long. For example, the easting is 52,492, northing 185,682. If that is the coordinate, you don't want to be writing such a large coordinates for every pile. It is easier to use the reference line program, and when you do that, you will choose the center of the first one as your first point, say the center of this one as your second point, and you'll be setting out in relation to this. If you know the distance, for example, 6 meters, every pile, for example, 6 meters apart, 5 meters this way. So this one, then the line, you'll have line and you'll have offset. Every pile will have a line that way and offset that way. Line that way and offset, line and offset. So for example, the line for this is 0 because you're on the same one, you haven't gone up, and the offset is 6. Line is 5, offset is 6. Line is 10, that's 5 plus 5, 10, and offset 6. For this one, line is 10, offset is 12. So every point will have a line and offset from here in relation to this line, and it's easier then to give the coordinates for every pile. It works very nicely when you have lots of points to set out where they are regularly spaced or are easy to work out the distance from the first point. The next one is area calculation. You can, for example, measure the area of an irregular shape. You can set up your instrument anywhere here, for example. You can sight to various points, corners, and as you sight, the instrument will calculate the coordinates for these, and it will tell you the area within these points. So you need to start from one point and go in a, it says clockwise or anti-clockwise, but you go in order around. You don't have to finish at the first one, you can finish at the one before, and that will work, that will automatically draw the line. That way it will complete this polygon, and it will show you the area in meters squared, and also in hectares it will show you the area. The next program you may be using sometimes is Traverse program. Traverse program is the one that you set up some stations around the site, and again you create a traverse, and this is your building site, and you will work out, say you start with the easting of 500 and 1000 for your first point, and then you work out the coordinate for all other points based on the internal angles and based on the distances between each leg of the traverse. So you first of all, you measure the internal angles between each leg. You set up here, you start to this 0.8, you start to this point, you read the internal angles, and then you measure the distances, and then you feed this to the instrument and it will give you the coordinates. The next program is the Roadworks. There's also some total stations have the program for Roadworks, some don't. The Roadworks is essentially you will give the line chainage for the center of the road. You'll have a road, you'll have a center line of the road, and you give a change, for example, every 10 meters. You give the coordinate for every 10 meters, and you give the heights, and it will help you to set out the road. So these are the main programs in total station. Some don't have these ones, some stop here, some stop there, but majority of total station will have these up to here. They will have these programs on board. If they don't have it, they're not worth to buy. In the next lecture, I will talk to you about total stations, the history, how they were made, what they do, what should prompt your decision to buy or not to buy, and what's the differences between various makes or various accuracies of total stations.